What is up, ladies and gentlemen? This is Dirk Hamel-Wood, and in this video we'll be discussing Chapter 11, the Environment, Section 2, Satellite Communication and Imaging. Imaging satellites. They have many uses in both commercial and military scenarios. These satellites, such as the GEOI-1, orbit above the Earth at altitudes of up to 680 kilometers. They are capable of taking high-resolution photographs of any place on the planet. The most developed of these commercial satellites can produce images with quality up to 0.4 meters per pixel. Some believe that military satellites have resolutions up to 12.5 centimeters, although this is unlikely. This is an example of what one of these imaging satellites would look like. And these are examples of the kind of pictures that are taken. Other satellites. Some other different variations of these use remote sensing techniques such as radio waves in the case of radar, lasers, LiDAR, or sound sonar to gather data when not available using traditional imaging techniques such as in areas where there's heavy cloud cover or in areas such as rainforests where the trees may cover some significant land features. Elevation data, terrain types, weather data, and maps of the seafloor are also examples of this data. These observations are not even limited to Earth itself. Detailed maps of other planets in our solar system have been compiled. Because radio waves, sound waves, and lasers are not visible to the naked eye, the returned data must be heavily processed in order to produce a useful visual of the data. As I discussed in my last video, analog to digital converters are also used. This is an example of a radar satellite which has collected data, I believe, on elevation, and this is the kind of output that it would generate in the form of a graph. Applications of satellite imaging. Weather monitoring is one of the most common applications of satellite imaging technology. Photographs and remote sensing are used to monitor climate and environmental change, specifically in areas which are difficult to access or too large to measure manually. Such as in deserts, it would be really impractical to have a lot of monitoring posts or sensors that are used to determine like weather and whatnot. But with a satellite monitoring system, you can get all that like climate stuff without significant hassle. For example, rainforests, deserts, and glaciers can be measured using radar imaging, allowing rates such as desertification, deforestation, and glacial retreat to be studied. These are all really significant indicators of global warming. Additionally, natural disasters such as volcano eruptions and oil spills have been monitored using similar techniques, such as the BP oil spill, which occurred last year, as many of you can relate to. Collection of data from infrared sensors enables land and ocean temperatures to be calculated, which is useful for making predictions about weather patterns. Again, weather satellite imaging. But another application is that using these remote sensing techniques, detailed maps of the seafloor can be generated. And since man has only discovered about 30% of the ocean floor, this is definitely a scientific revelation. Remote sensing satellites and probes have been able to collect atmospheric, temperature, and surface data from Venus, Mercury, and Jupiter. Data gathered by some of these probes on Mars has shown large trenches, leading many to believe that water once flowed on the surface of the red planet. There are additional probes en route to the outer edges of the solar system in hope to collect data from Pluto and its moons, even though Pluto is not a planet. Satellite imaging and remote sensing technologies were driven along in Maine because of military requirements, more specifically during the Cold War era arms race, when the United States and the Soviet Union used aerial and satellite photography to monitor the opposite side. This was especially crucial after the incident in which an American spy aircraft was crashed in one of these Soviet territories, leading to this huge scandal. So the unmanned radar satellites and remote sensing satellites were developed in response to that. Today, this technology is still used heavily by the military to monitor the development of nuclear weapons through tracking the electromagnetic pulses and X-ray radiation generated by this development. It is a crucial military intelligence gathering tool and has been used extensively in Iraq and Afghanistan. In addition to military usage, satellite data also has many uses in educational, business, and leisure scenarios, often used to build online mapping systems such as GIS or Geographical Information Systems. These are my references, and thank you for watching.